Maybe a couple of minutes past beginning time, so maybe we can kick it off. We have a bunch of topics to go through. Thanks, Laura, for adding those links to the chat. And let's kick it off with the first topic, the Pali. Are you on the call?
Yes, I'm there.
Feel free to take it away.
Yeah, okay. So I'm Dipali Kasturi. I'm a graduate student from Northeastern University studying information system. Today I'll be talking about Dependabot. So what is Dependabot? It is basically I'll just brief about what is Dependabot. It is basically a tool where our which helps our depend which helps our project for version update or to help our dependency to have to help our project to have secure dependencies in our project. So so why do we need so what is the current situation in our Ceph project? So if for example, if any developer is working through an error and he spends the entire day working on it, and at the end of the day he understands that the error was basically due to the version was not updated, and the project was being working on an older version of that project, which was eventually giving that error. So the developer has spent the entire day and it was not needed. What if this process of having an updated dependency in our project was automated? So how do we go about this? So we'll basically need to have a list of current dependencies and their version. So how can we get that? It can be through spec file. Also, we can get that for Python for requirement.txt for package manager pip. For in the same manner for npm we can get it using package.json. For JavaScript, TypeScript, or Angular.js. Also, for Java related dependency, we can have pom.xml or Go modules for Go language, and also have their versions in the listing. So why would we need to list the dependencies? These listing would help us understand the current version that we are using, and also if there is, we can check if there is any new version for that particular dependency. This will help the developer to save a lot of time. Also, if there is any current dependency which is not secure to be used, we can also check that. So here comes Dependabot. What does Dependabot do? It basically tries to update. It basically keeps your dependencies updated to keep our software secure. It how does it do that? It basically provides two features. That is a version update and provides security alerts. It checks for packages for its features in Ruby, JavaScript, Python, PHP, Elixir, Go, Rust, Java, and .NET. So what are the features? What are the features of Dependabot? So it provide. What does it provide? What does Dependabot provide? It basically provides version updates for its or our dependencies. Also, it provides security alerts for any vulnerable dependencies that are there in our project. So let's go with the first feature, that is version update. So what does Dependabot do into its version update feature? For any normal circumstances, if a developer comes across a dependency which needs to be updated with a newer version, that developer will manually go and correct the dependency and create a PR and go through all the process. So Dependabot comes into picture and it will check the list of dependencies that are there in a project, and also if there is any new version for that particular dependency, it will update it and also create a PR for that project. So all the effort for the developer is saved. And here's the visual representation for the PR that is created by Dependabot for version update. So we basically have the bump for this particular dependency node from 12.21 to 18.8, and it also has reviewers for the particular PR. So this is actually the actual representation of the PR. So we have the commit message. The commit message can be configured in a Dependabot configuration file, like the dependency node, which is being bumped from so and so version number. Also where it is located. So if any developer needs to go and verify all these changes, so he can check it through the location. Also through the description, we can understand if there are what are the additional features that are there in the new version and if it is needed for our project. Also there are reviewers, so that we can go add the reviewers for the particular ecosystems or package managers or languages related projects in our Ceph. So moving forward, we have the next feature, that is security alert. So so if there is any dependency that is there in our project which is not vulnerable, which is vulnerable and is not secure for our project, and our project might be prone to any malicious attack because of that dependency. So what does Dependabot do in this? It scans all the dependencies in our project and checks if there are any dependencies which are vulnerable or not secure, and it will give or send an alert in GitHub. It also suggests a fix, that it would create a PR for the closest non-vulnerable version for that particular dependency, so that we can know that we can place our dependency version to a safer version. So here's the visual representation for the alerts that Dependabot creates. So so we can basically sort these by severity, as in high, critical, moderate. So when a developer goes through all these list, he can sort these and give preferences to the severity. So moving forward, we look at the implementation. The implementation is simple and easy. We need to enable Dependabot for GitHub, which is already done for NPM package ecosystem and GitHub work actions, GitHub actions. We configure Dependabot for all the dependency ecosystems that are required for version update. Ecosystem is basically package manager. For example, your package ecosystem is NPM, package ecosystem is GitHub Actions. So in Ceph, currently we have already implemented ecosystem for NPM and GitHub Actions. Also, for getting the security alerts, we enable it in our organization for GitHub. And thus, for moving forward, we configure Dependabot for using dependabot.yaml in GitHub directory. So the configuration consists of the package ecosystem, that is pip, and the directory where we want to have these checks to be done on. We can also schedule this like on daily basis or give a specific time. The intervals can be like daily, weekly, or monthly, whenever we want. As said previously, in the version update PR, we can even have a commit message and add prefix like we had MGR dashboard for the dashboard related project. Then we can add reviewers. Also, we can limit the number of pull requests for that particular ecosystem. So we can have open 20 open pull requests for pip for this particular directory location. So with all these fascinating features, what can be the challenge in implementing this in our project? So as you see, like there are 56 open PRs and 153 closed PRs. So any developer working on Dependabot would get like on daily basis. We can have number of dependencies being updated from major version to minor version and etc. So we can have number of PRs being generated. So so the developer might get too many PRs for to review, and which might be not even needed for our purpose. So the solution is we can basically add reviewers. So currently in our project we have code owners. So so if we are making any changes for the directory dashboard, and through code owners, only the um, dashboard related team would get the alerts about these, and can review the PRs and approve them. Also, if needed, we can add reviewers explicitly, like we can add the team, we can also add the username, or we can add the organization. Thank you. And if there are any questions, I'm open to answer. Also, the mentors in my project who helped me through this is my manager, Christina, Justin, and Gabriella.
Thanks so much. That was a great presentation.
Also, yes.
Gabriella says, awesome work. I don't know if you can see the chat. I have a question for you. So
Yes.
when you were working in your internship, what was the hardest part about it? And what was the part that you liked the most?
At the beginning, as I would say, working on Dependabot one was one of the interesting thing, as as I didn't know, like I just had a problem statement that I needed to know how can I update the version, and like I went from scratch, like how can I go about it, like getting on, how do I get the dependencies and know the version numbers, and how can I compare it. And understanding this, I understood like how can I go about it and look around in on GitHub to or other contributors, what are they doing about it, and if I can understand what they are doing and apply it through in my project about it. So that was the most interesting part.
That's great to hear. And I think in the Ceph project, we've got we had Dependabot for some in some areas. I'm not exactly
Yeah,
sure
we
where.
had Dependabot for a dashboard related project that is basically for NPM, and but we can add it for others too, like for Python. There was specifically one PR that I saw that there was a update for Fedora, and if we could get that update, like any OS related major updates, so it could be really helpful for our developers that they can look for.
Definitely. Thanks so much. Does anybody else have any questions or comments for Ollie?
Thank you for presenting your work, Dipali. I think it's really useful, as we all understood from your presentation.
Thank you.
If there are no more questions for Dipali, we can probably move on to the next topic. Ronan? You want to talk about your super awesome scrub scheduling viewer?
Yeah. So let me start. My plan is to describe some of the changes that I hope to get merged or were already merged into Reef regarding scrub scheduling. The idea is to dedicate some 10-15 minutes to describing how scrub scheduling is handled in the existing code and why the existing code is built the way it is, and then what the changes that I'm trying to push for approval, and what will be the benefits in those changes. Now, most of what I'll be describing is now in a PR 49237. Just for okay. So this is, I said I'll start with a few minutes perspective. This is the way Scrub scheduling, Scrub implementation was designed, where when I started handing the codes, the basic operation was and is still like this. The OSD has a scrub queue, a queue of the owned PGs, those PGs for which and every tick, actually it's tick without OSD log for those code. Every tick, the OSD queries the queue and looks for the first PG that is scheduled to be scrubbed and scrub it. The PG held its as part of the PG class held the scrub related data that controlled the scheduling and controlled the behavior of the most important were a set of flags. There was probably you know the names. There was a large set of flags like rec scrub, mass tip scrub, etc., which controlled when a scrub will be performed to some extent, and what type of scrub, what level, whether it will be a shallow or a deep scrub, and controlled some other parameters. We'll talk about it later in more details. Okay, so I started working on Scrub like I said, 3.5 years ago. The idea was there to port it Crimson, which I never got around to. But on the way to doing that, I felt obliged to perform some cleanups and solve some very small number of bugs that existed in the code, and some features were added. So the first, to facilitate this, the porting, the first step was to extract most of the scrub-related code out of the PG class proper. A new class was created, the PG Scrubber. Each PG owns one of those. And the PG Scrubber encompasses most of the functionality that is required to perform a scrub. By the way, I'm talking without seeing any one of you and without hearing anything, so let me know if you stop hearing me. Okay?
Agreed.
Okay, and I don't see any chat, so I don't know why, but I don't. So
I'll let you know if there's anything in the chat. So far,
okay.
It's clear.
Thank you. Okay, so the first change, like I said, PG Scrubber. And when I tried to extract the PG Scrubber, I again encountered the issue of flags. And trying to understand those flags, and this was one of the hairy issues that I encountered. The first step I did was to separate those into two groups. One group was the set of flags that controlled the next scrub, the planned scrub, and the other were made part of the PG scrubber and were affecting the currently running scrub, the current scrub session. Okay, and there is a point in time when the scrub starts, when this set of flags is frozen. Now this is one side of the change. Regarding the scrub scheduling, in the first phase nothing was changed, and then I took out the scrub queue from within the OSD, made it a separate entity. Each OSD now owns a scrub queue, and the idea is mostly the same. There is a queue of owned PGs, but there was an added structure that was added, which is the scrub job in the middle. The scrub job holds the data required by the scrub queue in order to schedule, order, and initiate or ask a PG to initiate a scrub on a specific for a specific PG. So this is basically the situation, the main points of the existing implementation. A few points to note. Take a look at what happens when trying to schedule a scrub. Like we said, the OSD once every second, or on most seconds, there is some randomness there. The OSD asks the scrub queue for the topmost PG to scrub, and then make a just-in-time decision. What level of scrub is required? The level determination is based on the specific flags in the PG, those planned scrubs we discussed, and some environment variables. For example, are we allowed to perform a deep scrub? Are we allowed to perform shallow scrub? Whatever. What time in the oops. Don't know why. Just okay. All these decisions are made when we initiate the scrubbing of a specific PG. Now, this by itself is a problem because it means that we can never tell the user, or we cannot always tell the user what type of scrub will be performed on a specific PG in the future. It is a minor nuisance. And there are some other issues with this implementation as it was. The main problem that was encountered by our users is what happens if this OSD tries to start scrubbing, but there is a problem. And for this discussion, there are two types of problems. So let's cap every tick or most ticks. We are selecting the first PG in the queue as a candidate. We then perform some validation checks. Is the PG still there? Is the PG still active? Is it everything all right for scrubbing? Do we have the environment and the configuration, etc., to start scrubbing this PG? If all is okay, why is this? is this running by itself? If everything is okay, we are asking the PG to perform the scrub. And the PG then goes and I'm trying not to, something causes the slides to go back. I don't know why. Anyway, the PG tries to initiate a scrub by first reserving the replicas, and this is an important step. The primary OSD requests all the replicas to assign resources, and the resource is simply a counter within the respective OSD that says how busy is more or less, how many scrubs are running on a specific OSD. And this is a limited resource. The PG tries to reserve all the replicas, and once granted, we start scrubbing. That's the basic idea. And everything is fine unless there is an error. Now, there is a problem here. There's a problem here. Suppose we try to scrub, a PG is the topmost in the queue, and we try to scrub it. And then it fails to reserve the replicas. We discuss in a minute some reasons, but what will happen? We have already wasted, say, this tick, this OSD tick. We will not be trying any more PGs. We're not trying to initiate a scrub on any more PGs in that specific time frame. And because trying to reserve the replicas and being rejected might take time, might take seconds, we are wasting, in quotation marks, we are wasting more than one tick. And then we understand that this PG has failed in securing resources. Okay, suppose that happened. What happened the next time? The next tick. That PG is still the topmost. We will again try to initiate a scrub on that specific PG. Now, this problem was solved mostly a couple of years ago when we added, when we modified the scrub queue to have two queues instead. I don't understand this. Two queues instead of one. Here we have a PG, we have a queue of the regular queue to scrub and a second queue for those PGs that have failed securing the replicas. And those PGs are penalized for their failure. Everything's okay, Tina? Again, no feedback.
Everything's good.
Okay, apart from, I wish I understood why my slides are moving around. Okay, so this is okay. So this is the state as it was, and mostly this is how things are increasing, and it's pretty good. It works pretty good, apart from some issues. It isn't perfect. For example, we have handled one of the failure modes of a scrub, but there are some other rare things that might happen during a scrub session and might cause problems with the general handling of the scrub queue. For example, suppose one scrub session is stuck. Now, this is always a bug, but it happens. Usually it happens because we have an object that is locked indefinitely, and this causes the scrub to block. And then, if you consider what happens, we have an OSD that is running scrub for some PG, and this scrub does not terminate, which means that the OSD, the specific OSD, now has one of his resources locked for a long period of time. And during that time, that OSD has reduced capacity to answer other requests for scrubbing. For example, for those PGs for which it is the replica. It serves as a replica, not as a primary. So the effect of a stuck scrub is pretty spread. It's not just one PG that is affected, but it might be more than that. That's one example of a problem. And there are others. I will try to go. So I won't spend a lot of time trying to explain in this specific moment what the problems are, but just to mention some. For example, if we have a group of PGs that cannot be scrubbed, but they are high in the queue, we are wasting effort in trying to scrub them, to initiate a scrub. Now, it's not that we are wasting a lot of CPU, but mostly I think it's a lot of logs that we are creating, especially in debug modes. And this is wasteful and disturbing. Another issue, which is more a design goal than a problem, is the fact that the scheduling decisions are distributed. We are not each OSD makes its own decisions regarding those PGs for which it is the primary, and there is no central authority which decides which scrub should be scheduled as the next, which PG should be scrubbed at any specific point of time. Now, we wish to keep this way. The distributed, okay, see there. The distributed scheduling has the benefit of being easier to maintain and easier to debug than any cluster-wide system. I know we have customers, Ceph users that build their own central scrub management on top of what we are doing here. And one of the ideas, one of my goals is to create a system which will make this central system not necessary. I'm trying to cover most of 90 or more % of what might be achieved with central scheduling while still maintaining the distributed scheduling. Now there is the issue of cluster-wide effects problems. Like I gave an example. What happens when one scrub on one PG, probably because of one object, has a problem? It is an issue. And there is an issue that is not fully investigated, but happens. We have clients, we have Ceph users that see a long tail of PGs that are never scrubbed. I have some theories about that, and even some things that some reasons that already known, but you can see the point. You can see what might happen here. Suppose you have a group of PGs that for some reason constantly fail. If this group is large enough, it might mean that some PGs are starved and never get to scheduled for scrubbing. And the last two issues, observability. It's not easy, even for those who know the algorithm and know the way things are done, to understand what, or quickly understand what scrubs will be performed on which PGs in the near future. And there is the issue of code maintainability. So let's talk about the main changes in Reef. And there are three changes in Scrub, three main changes in Scrub scheduling. And this is, here is the beginning of the main part of the short, it's actually the shorter part. We have discussed the issue of the object that's called scrub job. Scrub job is something that is shared between the scrub view and the PG scrubber, and describe and holds all the information regarding the scheduling of a specific PG. What was added in Reef is a scrub target, an object called scrub target. Scrub target has, you can see it here, I'm not sure if you see my pointer, but a scrub target has an urgency, which we'll talk in a second, target time, a deadline. Target time and deadline are what we have now, the same, and a not before time, which we'll describe in a minute. And each scrub job, which means that each PG through his PG scrubber, each scrub job holds two targets, two scheduled targets, a shallow target and a deep target. And the main change is that the scrub queue, the OSD scrub queue, is now composed of those targets. If you take a look at in the left of the slide, this is how a scrub queue might look like. You have entries which specify the PG and the level. Okay? So in this specific example, PG 1.7 appears twice. The shallow scrub is first because of whatever parameters and timestamps are relevant, and PG and the deep scrub for that specific PG will be later in the queue. Okay, is this clear? I won't wait for. This change by itself helps the visibility, because now when you look at the scrub queue, and we'll see how it looks in the logs, dump commands, you can clearly see what types of scrubs are planned, and we'll see in a minute what other types of information will be available to make the scrub queue easier to parse for the user. Okay. This, apart from the visibility, this change allows us to do the following. It enables the next two changes. One is the urgency, which is marked here with yellow. We talked about the flags. To remind you, there is a set of flags now in two groups. One is the requested or the planned next scrub, which define how do we want to see the next scrub on a specific PG. For example, should it be a deep? Must it be a deep scrub? Should it be a high priority scrub, etc.? This is the list of flags taken from current code. And we have the operation flags that affect the currently running script. Here we have a limited number of those. What this urgency field is a way to encompass most of the functionality of these flags as a priority or urgency. Priority is other things, as a way to specify how fast we want or how urgently we want this specific scrub. And remember, we have two targets, which means we have different urgencies for the shallow and the deep targets for each scrub job. So it means we can specify how urgent is the shallow or the deep target for each scrub job. And if you look here on what types of urgencies we have, you can see that we do have the periodic regular, which is what we expect most of the time to see in a regular cluster. Okay, but we also have some other urgencies. For example, penalized is the implementation of the penalized queue, which we saw earlier. Now we don't need it. It's just one more urgency with some specific logic around it in the same hierarchy of urgencies. We have the overdue, which is another behavior or another functionality that is currently handled sometimes with flags. Overdue means that we are beyond the target of beyond the deadline of a specific target. And again, because we have two different targets, the shallow and the deep, we can do that. And then we have the higher priority urgencies, operator requested, must, which is specific to something that we have now, which is after a request from an operator with repair mostly. This is mostly why we have must. And we have the after repair, which is an immediate type of scrub, of deep scrub that is which is performed after repair in some instances, and should be scheduled immediately after the repair, and that is why it's given the highest priority. All in all, those flags encompass most of the functionality of the existing scrubs, existing flags. For example, suppose there was the flag that earlier, the must deep scrub. See? Here it is. Oops, why is it moving? We have the must deep scrub here below. The must deep scrub is set for either scrub after repair, or if the operator requested, like I said, either a deep scrub or a repair, which means deep scrub with repair. Now we don't need this flag because the functionality is encompassed in the must and the after repair urgencies in the urgency enum that I showed you. And the same holds for the other flags that you see. None of them is needed anymore, which means that a lot of code and a lot of areas of inclarity were removed and improved. For me, as a maintainer, not as a user, this is one of the main benefits of the new implementation. The other and the last, the other change. Why is it?
No worries. We can still. Yeah, it's weird, but we can still get your presentation. No worries.
Yeah, I don't know why it's just moving around like. Really don't know. Anyway, the point is the not before that you see here again in the yellow there. Oh, yellow. I hope it's yellow. Probably might be green.
It's yellow.
Okay. Okay, and the not before. Not before is a time point, and that is set for each target, each scheduled target, and will prevent this target from being scheduled until it is reached. What it's good for? This is what we said earlier, that suppose a PG has failed to start, or a PG failed to start scrubbing, or failed during scrub for whatever reason. This enables us to set a new not before in some time, X seconds, n seconds in the future, which with the n depending on whatever factors. For example, what was the reason for the failure, how many other PGs are waiting, etc. But it at least enables us to set a time that and make sure that we will not try again for this scheduling target, and at the same time enables us to keep the urgency, the target time, the deadline, all those parameters that say how badly we need this scrub, when we will be able to, but only when we will be allowed to retry it. Actually, the idea of the not before was why I started making changes to scheduling in the first place. But now with the urgency and the idea of the scale targets, there is a whole package that improves the behavior and the visibility of the whole scrub scheduling. Now, a few points that I want to make if anyone will be looking at the code, we'll try to understand it. Let's take a look at the scrub queue. The scrub queue is ordered first by those jobs that are those sched targets that are ripe, which means the not before has arrived. And for those that are ripe, they are sorted by urgency, then deadline, then target, etc. And all the rest of the jobs that are not ripe are sorted first by the not before. Which means that if you have 10 jobs that have the not before in the past, the urgency will determine which scrub will perform first. Okay, that's one important and one reason that one complication in the code. But for now, I think it's a requirement. Another point to just to mention is here the next shallow and the next deep. There are many instances where a change is made to the target. For example, when a scrub terminates, or when a scrub ends, or if a configuration changes or if the operator issues a command. In all those cases, a target is modified, but before it is modified, the specific target that is modified depends on whether we are currently scrubbing or using the specific target for scrubbing. And to allow this, we have some kind of double buffer with the next shallow or next deep entries managed by the scrub job. Most of the code that is not aware of this, but most of the code just asks, give me the shallow target that is modifiable, and will usually get back the shallow target, the main shallow target. But in some cases, the only cases, if we are currently performing a shallow scrub of the specific PG, the modifiable target will be the next shallow. Okay, this is something that you might see in the code. Okay, so this is the basic design. Here is more how it might look to a user running a query on the PG. You can see here the shallow. I don't know if you see my pointer when I move it.
I don't see it.
No, yeah.
Okay, so I'm just pointing in there. Okay, you can see the. Anyway.
Oh, now I see it. Interesting. I think it just goes away after a while. It's very tiny.
Okay. I don't see an option to start it. Okay, to show it. But anyway, there is. If you can see, for example, a PG, you can see the shallow target parameters, left, middle, left, and the deep target, right, upper columns. And you see a reference to the nearest of the two. This is something that is always maintained just to allow for easy listing, dumping, etc. The jobs, the scrub job maintains a pointer or reference, whatever, to the nearest of the shallow or deep target. This is one example of listing. Here is an example of how things might look at the logs, in the logs. Usually, okay, this is how, look at the first line, this is how a scrub queue is, this is how a scrub queue might appear in the log. You can see that we have a PG.1.0 it's not ripe. The closest target is on 7th of December, etc., etc. And we have the closest target here. It is a shallow one. It's not before is whatever. It will be a periodic regular urgency. And here are the rest of the parameters. And there is the issue field which might say why we failed the last time, if we failed scheduling this specific target. Okay, and below that you can see another example of here, in this case, an operator requested a target. You can see the specific urgency appearing here quite clearly. Okay. And when we are looking at log lines that are not grab specific, as you know, whenever we have a PG mentioned in the logs, there is a long string of data about that PG, and the scrubbing state is one of the data items. Usually it was the old flags with, and once those flags were segregated into two classes, in two sets, like I said earlier, it wasn't very easy to understand what's going on with them. Now you can, I added again a clearer understanding of a clearer depiction of what the current scrub or the next scrub will be. For example, take a look at the second line, sorry, PG2.5. PG2.5 is currently active and clean. It is not scrubbing, but there is an operator request for the next scrub, for a shallow scrub. That's why you can see here, as part of the PG status line, you can see the next scrub will be a shallow and will be operator level. The first line, PG2.7, doesn't, oh God. The first line, PG2.7, does not have this operator request, and this next scrub will be regular, periodic. In this case, it doesn't appear. We don't need to just mess the logs with data which is meaningless. And the last line, the third line, PG2.5, is now scrubbing. And now, in a different format, you can see that the current scrub is shallow, is mandatory, which means it was forced, does have a meaning in the code, and it was operator urgency. Okay. I think that's the main issues. That's the main idea of the change.
Thanks, Ronan.
Are there any questions?
So at the beginning, you were talking about idle slots when PGs fail to get remote reservations. I thought you were going to do something to change that, but I didn't hear anything about it. Did I misunderstand?
Okay. 1 second, let me just stop the. Okay. Regarding reservations that failed, there are a few changes that were, and a few that are planned. I hope to get them in. One issue was we have now a system that reports whenever a reservation request is late or delayed. Now, this is in final stages of testing. I hope to merge it in the next couple of days. So this specific issue is halfway to be handled. We had the issue of scrub resources locked by scrubs that are blocked, which I mentioned earlier. Now, what does already exist in Quincy is quite recent change, is a warning in the cluster log. There isn't a lot I can do when a scrub is blocked on an object, but at least now there is a clear warning in the cluster log about it, for what it's worth. There is a PR in the works, which I'm not sure I will be able to get ready in time for RIF, which will react to such locked or whatever blocked for whatever reason scrubs. What else? There were a few other Okay, that's more or less what was done.
So I guess it seems like the main changes are that you collapsed a bunch of Boolean flags that were confusing if they combine into a single enum, and then the scheduling has that not before feature and it reorders live.
They're not
I wasn't totally sure about all the data structures and which parts were like the key bits.
well, the key
Yeah,
bits are those three.
yeah, I guess, Ronan, I think even I'm trying to get to that question is that you earlier mentioned that we're wasting a tick cycle or more than one tick cycle if something gets preempted, right? How is the urgency class or whatever, the enum, solving that problem?
Okay. The urgency by itself does not. This is not. I mentioned it just as one of the problems, not the only problem we have. I'm sorry if I gave the wrong impression that I'm solving this here. What I am doing is enabling. Well, I'm solving some of the problem of the long tail that is caused by such breakers by using the not before. This does have an effect on what will be the chances of starvation of PGs. I am hoping to use the same mechanism, the same enum, to handle other types of runtime or scrub time failures. But yeah, the main change in solving this problem is the not before.
And from a user perspective, a lot of the old flags and stuff have now changed meaning or do not exist, right? So there is going to be a lot of documentation that probably would be required for this.
Yes, although even in the last, I think already 2 versions of, we already have some name changes because of the separations of the flags. We had planned flags and current flags, and names were repeated or changed, and it doesn't seem that anyone noticed that. Or
so the PG state that you have now, like instead of like you have active, clean, scrubbing, now the shallow operator mandatory, all that will show up in Ceph status as well, or it's just for the PG like the log line?
Well, that's a good question. It should appear. If I didn't make it appear in the status.
Yeah, so that's where I'm coming from. So if users suddenly start to see all these new fancy words, they probably will be confused about what's going on. So that's why I emphasize the importance of documenting this.
Yeah. Okay. I'll try to clarify what changes and what not. For example, if you're doing the ls by PG or whatever, you won't see change. I'm not changing because in this stage I'm not changing the interface that transmit the data to the monitors. So I'm not adding data to this. Okay, and 1 second, and before, there is one node which I didn't include in this presentation, Greg, regarding what you asked earlier. One of the next PRs that I'm working on was specifically regarding the issue of replica reservation. I've already included some initial changes for that in the current PR. The idea is that if the request for reservation from a primary to the replicas will include the urgency as one of the parameters, and an OSD which refused an urgent or high priority, not urgent, high priority or not periodic request for resources will be locked from granting those resources to anyone with lower priority for a time. This will at least give a chance for high priority scraps that are constantly delayed because of an OSD, a replica OSD, which is very busy, to be sure to advance in time. And this change is not ready for inclusion at this point, but it is part of the solution.
So is there any user visible change to like scrubbing constraints or inputs yet? Or is it just you think that by adding the not before it schedules better?
It schedules better. I am exposing the data because things that the clients want to know why things are scheduled or not. There are a few knobs that are added.
Well, where's it exposed if you're not changing what the monitors see?
It is exposed in query, wherever I can send a JSON, I can add data. If you don't consider query as a user operator option,
Okay,
then no.
so I guess let me rephrase that. Are you like removing fields, or is it merely or is it just the adding of a little more diagnostics?
The original, okay. I can't give you a full answer. The idea was just to add. I'm not sure, but I did. I wasn't able to fully keep what you had in a query request.
Well, okay, so let me. I guess what I'm getting at is that it seems like you've added several new data structures, but the important parts, as I understand it, are that it's got the not before field, which is used in like ordering the PGs that get chosen to scrub, and
Yeah.
all the bools that were mostly exclusive from each other, although I'm not sure if they all got collapsed into a single enum. And that's fine if that makes it easier to reason about and improves the scheduling. But our more advanced users have a lot of knowledge that they've developed about how scrubbing works, and as you referenced, how to like control it by people have built their own scrub scheduling engines that run outside Ceph. And so if this is like at the moment just these little things, but then that's one thing. But if we're expecting to like massively change the way scrubbing works, so all their learned knowledge and encoded knowledge and like their algorithmic engines breaks,
Greg, let me stop you there.
That's something we need to be really careful about.
Can y'all hear me?
Yeah.
Okay. Forcing a scrub's still going to work, so all that stuff's still going to work.
Okay.
The data structures people rely on are the last scrubbed stamp or something in the stats and the ability to force a scrub.
And
So none of that's going away anytime soon.
Yeah.
Or, ever.
And what did change is that when you do a dump, this is a user visible change. What you see, the scheduled time is now the not before, not the actual target, because not before is actually when you might hope to see the scrub.
Greg, if people are relying on detailed information of PG queries to do this work, then they'll need to adapt. But I don't think they are. I think they're just using forced PG scrub.
Yeah, I'm just trying to make sure I understand the sort of scope of what's changing in what places.
Yeah, I think we should definitely like add it in pending release notes and stuff about like if any of these have changed meaning or do not exist and what is new.
Yes.
Well,
Yeah, to pick up the other
if
statement
they've
earlier about
changed meaning,
documentation, it's not enough to note it in the release notes. You have to actually find every reference in the current documentation and fix it as part of your PR.
yeah.
But hopefully
and
these things don't show up prominently in the documentation.
And if something's changed meaning, it just needs a new name. Like we can't be trying to remember which release has which interpretation of a keyword.
I think a lot of the things that Ronan is talking about here are really internal details to the scrubbing machinery that aren't exposed very much at all in the docs or the user interface. More like the internal system introspection tools like evidence doc commands that most users aren't using.
I mean, yeah, but anyone who's providing support doesn't want to have to remember that stuff either.
That's a separate question from UI.
No, it's not. Supportability is part of user interface.
Well,
and
whether
experience.
there's separate questions or not, I support the idea of not changing the meaning of a thing without changing the name. It's confusing whether it's in supportability tools or in UI. But we can take that on a case-by-case basis. It may depend on the details.
I agree with the main lines. Yeah. But like I said, hopefully I hope to get, not sure I will be able, but I hope to get the priority in reserving OSD's time, but it will be hard to get it into.
Jotted down some notes in the Etherpad, but if there's anything else we want to remember, here's that Etherpad to add to. I wrote in his note about we should add a release note about anything that has changed meaning. Are there any more questions for Ronan? All right, I think
seems like a good good
restructure.
Sam. Looking forward to the PR.
Thanks.
Yeah, a huge plus to simplifying all of these flags. They've come to bite us every time we've looked at something getting stuck and slow and not working. So simplify this logic going forward, that'll be a huge achievement. So thanks for taking that work.
Trying to simplify my life.
There you go.
Okay, thank you. Thank you for the time.
Thanks, Ronan. The next topic on the agenda is PID assumptions. There have been some ongoing conversations in the Rados team about what we should assume in terms of PIDs. I don't know if there's any one person that wants to kick off the conversation, but I'll leave it up to whoever wants to start.
So yeah, this is just a general topic for discussion based on something we saw in a recent case that came in. Probably Sridhar, you have a background on what was going on. Maybe you can set context and then we can open it up for discussion.
Yeah, sure. How can you guys hear me?
Yes.
Yeah. So, like Neha mentioned, this specific issue relating to PIDs, this came before when one of our customers was trying to run a scenario involving restart of all the Ceph daemons. So the scenario basically involved graceful and ungraceful restarts of all the Ceph daemons, and the expectation was that after the restarts, everything comes up fine, and then cluster the connectivity and all the stuff happens properly. But during one of the these tests, it was noticed that a bunch of OSDs they were not coming up fine. They transitioned into the booting state. As you know, the OSD essentially transitions from init to booting and finally to the active state after restart. So a bunch of OSDs were noticed to be stuck in the booting state forever, leading to the mons eventually marking all those specific OSDs down after the time period of around 900 seconds. So this is the observation, and this issue was consistently being reproduced in the customer's environment. And so we requested QE to reproduce it locally, and they were able to do that as well. So essentially what was happening was, this is a containerized environment, and the customer was running ODF 4.12, if I'm not mistaken. So from analysis of the logs, it was pretty clear that the OSDs that were not coming up, those had a specific PID values being set. In a containerized environment, we essentially expect that the OSDs would have a PID value of 1. That essentially tells Ceph that the OSD is running in a containerized environment, and then it goes ahead and generates a random 64-bit nonce value. So that actually helps Ceph to figure out that the incarnation of an OSD that goes down and comes up. So essentially, in this case, what was happening was, for a bunch of OSDs, the nonce value didn't change across reboots, and as a result, the those OSDs that came up, they were marked as do boots, and essentially they never really transitioned into the active state. And it was through Greg's input that we finally figured out that the issue with the PID values, and we essentially got back to the customer to recommend them to use I think there's a environment variable called Ceph use random nonce. If either that should be enabled, or the PID for the Ceph daemon should be set to 1. So essentially that was the issue, and right now we don't understand how this PID value is getting changed to the PID of the OSD. That is not expected, but at least we have a workaround where we can set a specific environment variable called Ceph use random nonce, and that should help the OSDs to come up with a new nonce, and Ceph should ideally identify that this is a new incarnation of an existing OSD, and that should eventually help the OSD go into the active state. So this is the brief background about what happened in this case.
Thanks, Sridhar. And I pasted a couple of links in the chat to provide more context in terms of code around what assumptions are present and what assumptions were broken. It seems like the assumption in Rook was that the PID is always going to be 1, but that clearly was broken in this case, because of which we encountered other issues. But I think, Radek, you also had an experience of something like this in Crimson. Maybe you can elaborate on that, and then we can open it up for discussion.
Yes, I encountered this issue when porting Crimson to Rook. The main symptom were problems with peering. A lot of misdirected, mishandled peering messages. This was because in the nonce selection, basically one of the responsibilities of messenger is to translate identity into a tuple of network parameters like IP address, this port, and also nonce. We use nonce to distinguish between different instances of the same daemon, basically to detect restarts. And in Crimson, the nonce selection logic was that it was depending on PID. If I recall correctly, the assumption for containerized environments was that we are randomly picking up a huge integer if our PID is equal to 1. In other words, init. But in the Rook environment, if I recall correctly, it was a long time ago, the PID was 2, and we ended up with nonce always set to 0. I think this is quite similar to what we was seeing recently.
Thanks, Radek. So I guess the general idea is that with this new discovery, earlier Ceph ADM, the PR that I just pasted, was always setting this environmental variable. Now Rook is also doing the same. Now the question is there any other improvement that we can do in this area? And Greg, you had some thoughts around this, right?
Yeah, so I think Reddit covered this with just in short. Like, we use the nonce to disambiguate when entities are new at the same address and when they're an existing instance. And so it needs to be different on, every invocation of a daemon, and on, respawn or whatever. And once upon a time, we used the PID because, in 2007, PIDs were mostly random. And then most of the daemons except the OSDs now just use a random nonce because we started seeing cases where they weren't sufficiently random, and so we were getting these conflicts. Obviously, it happens all the time in containers now, but it also historically has happened a little bit in just systems where you're starting a lot of processes and the number of IDs are constrained or something. And I don't remember why we kept trying to just use the PID for the OSD. I think it was just so that it was easier for developers to map the messages they were seeing on other servers to which OSD daemon they needed to go run GDB on or something elsewhere. In which case, I think we should just get rid of the PID mapping and always randomize every time so that we never ever see this again. But maybe there's some other constraint I've forgotten about that we need to account for.
That is interesting because the code that I pasted, and that's messenger level code, so it's not specific to the OSD. So are the other daemons doing something somewhere to override that logic?
No, you have to. You can tell the messenger how to select your nonce, and this information used to be given to the messenger. It was put in I think one of these PRs that Sage did is actually where it moved into the messenger layer from the invoker. And I'm pretty sure the OSD is the only one that tries to use my PID version. The monitor and the MDS for sure, and I think the monitor are just random, and have been random for many, many years. So this is like a code path that the OSD chooses to use, and that was put into the messenger for the OSD to use, that the others don't.
So pits have pretty much one property that makes them attractive for this, and that's that the operating system goes to quite a bit of effort to make sure that it doesn't reuse pits for a while. That's the reason why we use pits. So I'm with Greg. I don't think there's any reason we actually have to do this. If we randomize in a sufficiently large space, we'll get a stronger guarantee. There won't be any possibility of failing to set the environment variable. And I've actually never used the nonce to map to a PID. I actually forgot that it did. Am I alone in that?
I mean, I have done it at least once in my life, but I forgot that the OSD did it this way either, so it's been many years.
Yeah, I mean, we never had to look at this until this new issue came up, to be honest, right? So it never seemed to be a problem, but maybe underneath it was causing issues in other edge cases. But,
It probably hasn't been, but this is more like, do we need to maintain 2 code paths or can we just maintain 1?
I'm all for simplifying. And as far as I can understand, historically it was done for some reasons. Those don't stand anymore. So just using a random one makes sense to me, unless there are any other disagreements. All right, I'm not hearing anything, so we
Just a quick note.
Yes, go ahead. Ryan.
I found the very old case about the case in Crimson. Also, one of the comments is actually about the nonce selection logic. Let me pinpoint it directly here. Here is the link comment with nonce selection snippets.
So this is the Crimson equivalent of what I pasted, I think, right? That's what it is doing if it's finding out. Yeah.
It's the report from investigation a long time ago.
Yeah, so my point is that if we can simplify this logic, even Crimson Classic can just use a random nonce, and then Ceph ADM and whoever doesn't need to, set environment variables.
Still, somebody could point out, okay, they are random, which means that there is very, very unlikely, but still existent case of running into nonce clashes.
That's actually handled. When the daemon starts up, it checks the OSD map to see if it actually grabbed the same nonce, because that's already possible for PIDs. So, yeah.
Perfect. Cool. Good to know.
That's actually what causes these loops. The OSD starts up and goes, oh, I got PID 1 again. Oh, I got PID 1 again. Oh, I got PID 1 again. And it just keeps restarting.
Cool. That's pretty much it. Anything else on this, or should we move on to the next topic? Not hearing anything, so over to you, Adam.
Hi, guys. I would like to very shortly talk about an issue that we got. Basically, we encountered customers who, due to some problems, not even important, were able to run OSDs multiple times, meaning 2 OSDs using the same block devices were running at the same time. That, of course, led to all strange and initially difficult to understand corruptions. That's it for the background. It mostly happens when we use containerized environment, and the reason why in general, we do have in BlueStore mechanism to protect against running object store multiple times. We just take logs for each block, each device that will be used for data. And in addition, an extra file called FSID. The problem that we had was that two different runs of the container recreated all that access files, meaning they used Ceph object store tool or equivalent to recreate BlueStore data path dir and also create all the links to devices. And the logging we were taking was inode based, meaning when files were recreated, we no longer actually were logging against the other OSDs that could still be running. There is that I assume for make it work, that the links in our BlueStore path were to block devices, and our the logs we were executing were against inodes that were block devices. But if there would be some mechanism, and I assume there must have been, that will also recreate a block device inode, then we got completely different set of inodes and two OSDs can run. I tested that on containers, and the only way I could see to block locking on the other OSD was to open the block device in an exclusive mode. There is it seems a bit extra implementation in Linux kernel to handle block devices differently. And if you open a block device inode, then you really get locking for a device itself, not only the inode. Hence, the PR I created. It's not that I'm stating that this solution will be working for all the cases. It's just the one that I wasn't able to break. So I would welcome any input on how can I make that exclusion maybe simpler or more secure or more robust, whatever. That's it.
Thanks, Adam. So I can relate this one to this tracker as well, where we are seeing the similar issue in the ODF environment, where the BlueFS got corrupted because the multiple Ceph pods were running against the same device, you can say it. Hello?
Yep, I can hear you.
Yeah. So that got actually fixed from the Rook side. Let me just bring you that one. So they are handling it in a bit different way in the Rook, just to prevent like multiple OSTs, multiple daemons using the same device, you can say, OSTs.
Can you shortly summarize what is the technique used in that PR? Because I don't have time to reread it.
So what they're doing, at least when I went through yesterday, so it's basically they're using the kind of like the OSD pod uses like the either the host path. Host path I think means like it's actually using the what do you say, like the system, like where the container is running, right? So it's using that path and probably creating some file. So make sure if any other daemon is coming up, it can't lock that file. So let me just go through that PR. It's a Rook one, so it's a bit.
So the idea is that
No,
there is a file created. Sorry.
Yeah, go ahead, Ron.
The idea is that the file is created with the name of the hardware, and just to make sure that they are not don't see it twice.
Wait a second.
Not sure I understand.
I'll just file patch and config directory.
I think the fact that it is a Rook PR makes it more or less irrelevant here, because the point of this exercise is really to protect from something like this happening at the lowest layer possible.
Yeah.
And the opening the block device with O exclusive, which is a Linux only thing, but then we don't really care about anything else here, at least for OSDs. That should be fine. So whatever Rook is doing, first of all, that clearly didn't work in this case. But also it's a thing that orchestration tools come and go, things change. Those changes aren't always acted by Ceph maintainers. Sometimes they're either considered to be trivial enough and no one asks. Sometimes it's just that people just don't understand how dire the consequences can be of for example, disabling PID files, as the case was. So all of this really points at the need to have this implemented at the lowest layer. So what Rook is doing, I mean, that probably doesn't shouldn't be a factor here, simply because we need to make this work independent of Rook or any other orchestration tool.
Yeah, I think that's understood and agreed. Just that the idea was just to see other mechanisms, not to use them. Other techniques, to learn what other techniques are there. Not, of course, we need to solve it in the lower level.
Yeah, that makes sense. Yeah.
Or if anyone knows how to cheat Linux into allowing multiple opens for in exclusive mode in containers or in raw, then I would like to hear about that, because my goal is to make it also protect against running tools. It happened that sometimes we were running Ceph BlueStore tool against an environment that already OSD was running with that devices, and it let us do it. So that I would also like to protect against.
So have we tested this? If Linux always respects the O-exclusive flag, even in a container, that would be great.
I tested that in container on Ubuntu and on CentOS 8, but I did not do any extensive tests.
The other thing is, when we create these containers and run them, we could be mounting the var directory we use in a mode that actually shares between containers. That would help. I actually think we should do Ilya's suggestion anyway. I think the more ways to prevent multiple accesses to a block device, the better. But we could also be doing that. It would mean PID files, all that other stuff would still work, which would be nice. Might be worth
I would really be
investigating.
glad to accommodate as many possible logs as I can.
Yeah, well,
Meaning
that's actually was like I think I commented on the PR. That was one of the questions. Like, if all exclusive thing works, and it really seems to be the thing like that actually works, that can be fooled around with. Then do we really need the existing open file description locks, like the flock thing? Is it still needed? Because the less it's just additional code that tries the OFD lock, then if that doesn't work, falls back to flock, and it's like if none of that is going to actually bring any value with all exclusive change in, then I think we should consider getting rid of it instead of like you said, trying all possible locks and locking everything that we can get our hands on.
Yep.
Counter proposal.
Usually I am in the same idea. I would like to simplify by passing even one of those logs that could save us. Just seemed for me too great.
You mentioned that the block device exclusive flag is Linux only.
And BSD, it seems, but not tested. I did not test on BSD.
Well, I've always thought that it was Linux only, but maybe BSD picked it up as well. I'm not sure.
Do we care about anything other than Linux and maybe BSD? Like, we care about Windows, but that's only the client, right?
Right. That's why when I was mentioning this, I underscored that this is OSD, so we don't really care about anything else.
Well, I'm asking because that would be specifically a reason to retain the old mechanisms. But if we really don't care, then I guess I don't care about the old mechanisms either.
Yeah, so I mean, we're certainly not going to like. I don't think anyone is planning to run Ceph clusters on Windows, and we could research the BSD question. I think it would take just a basic grep for the FreeBSD kernel code to determine that, if it's not documented in their man pages, that is. So that's a question that I'm not sure if we say we care, then yes. But then again, the flock mechanism can be bypassed. So it takes it takes some effort, but the container tooling makes it very easy. And again, I'm not sure what is the state of like. Because the container tools that we use on Linux that make this very easy are probably not supported on BSDs, and that would mean that flock based protection probably carries more weight there because it's going to be harder to bypass. But if FreeBSD supports or exclusive, then obviously we should just claim that it's supported, and in my opinion, just drop the flock stuff.
My main question is if this new method will work when we do user space IO stacks, or if we'll just deal with that bridge when we get to it.
It's up to the backing store. So this stuff lives in BlueStore, right, Ilya?
This stuff is in our kernel device stuff. It's not inside BlueStore per se, but it's only used by BlueStore.
Yeah, it's owned by the store. So if we create a user device stack that implements object store, it will be the responsibility of that stack to provide the same guarantee via whatever mechanism.
So that's fine, but do we have a good way to like make that explicit or make sure that's not forgotten when reviewing them?
It's not the most dangerous thing you could do incorrectly when creating an object store implementation.
Yeah, but it's one of the very dangerous ones that's pretty easy to not notice.
I mean, we can add a comment to mount in the objectstore.h file that says BT dubs, this is required to provide exclusivity. But that would be good enough for me. Like, I don't know what else we could do.
Well, I'm thinking
We can
we could
even
add a stub function call that's like verify exclusive locking or something.
No.
Why not?
We can make a unit test that tries to mount twice, and that should
Well,
not be.
We don't have any unit tests that apply uniformly to all object store implementations. I think a comment's enough. Like, we have 2 object store implementations right now, BlueStore and dstore and FileStore, right? Like, these things don't come up that often. We don't need to be that prophylactic about it. Like, this didn't happen because someone forgot to implement it. It happened because the implementation didn't work correctly in this environment.
I would even say that it ceased to work correctly.
Right. So I don't think we want to overdo the protection against that version.
Okay, so I will modify the PR to get rid of flock and just rest with O exclusive, and we will need to find a way how to best test it in most conditions.
Well, I think we agreed that we need to, like, if we care about potentially supporting BSDs, then we need to check whether O exclusive for block devices is a thing there. Because you mentioned, like, I'm not sure, did you check the man pages, or because for some reason I always thought this was a Linux only addition, because it certainly originated.
I checked man pages. I checked man pages only.
Oh, okay.
We've had a couple of people try to contribute BSD friendly code. We could find the email address for one of them and ask them.
They also only supported FileStore at the moment on BSD because BlueStore already used things that BSD didn't have, I believe.
Oh, there you go.
Made the effort to do it.
Yeah, but the FileStore deprecation, they might, I know that they were in the process of working around the issues they're having with BlueStore. So with FileStore deprecation on the horizon, they might want to use BlueStore. So we should cater for that case as well, right?
I think sending a message to Ceph Developer and CCing one of them would be sufficient.
Yeah, I think William is the one who's super active in the FreeBSD communities.
Yeah, and just to kind of, I was specifically commenting on the kernel device implementation with this exclusive PR doing 2 types of locking, and that seems to be not desirable to me, and so leaving just exclusive there is probably the way to go. But that doesn't say that we can't continue f-locking one of the metadata files, like, for example, the whatever it is, the FSID or something else in the in the OSD directory, and have that be common for any with a user space IO stack with a user space block device, essentially. So my comment only extended to the implementation of the block device interface, not to to BlueStore, so not to the object store implementation. The object store implementation is free to use whatever locking mechanism to lock whatever metadata file it sees fit, in my opinion.
Okay, Ilya, you mean you would like to have locking a separate thing from block device implementation?
No, I'm saying that
I'm
saying that we could, like, there's nothing stopping the object store implementation from doing additional locking if it wants to do that. The thing that I brought up and what I was mildly objecting to was the kernel device implementation, specifically doing two types of locking on the same entity, like on the same on the same block device, right? On the same thing. So that seemed excessive to me, but we could still, like, an object store implementation could still lock, for example, an FSID file or a superblock file, which is not a block device, with conventional locking mechanisms which are portable and supported on, just generally on POSIX.
What are other users of kernel device component other than BlueStore?
The one I'm aware of is the persistent client-side cache in RBD. So it has two backends. It can use a PMEM device like a PMEM card or just a standard block device. So with the intent of it being an SSD. So that's a second user. There might be a third one. I'm not sure.
Does this user require locking, or is locking only needed for BlueStore?
This user, well, so the locking is, there is additional locking at the librd level via the exclusive lock feature, but I think it actually uses locking already, right? Because the lock exclusive flag, or it's not actually a flag, it's a field in the block device class, or maybe kernel device implementation. I'm not sure, but it's a member field, and it defaults to true. And any open method, like when you call block device create and then block device open, if you don't do anything in between, then open would do an exclusive open by default. So this means that this second user, this SSD cache, already uses exclusive mode. It just doesn't rely on it because there is higher level locking within librd. To the best of my knowledge, the only reason to request a non-exclusive open is to actually call a method in between create and open. There is something named set no exclusive lock. So that's an actual method that you call, and that method unsets the member field. So it sets, it changes it from true to false.
The reason why we have set not exclusive open is because we have two components in BlueStore. One is BlueStore core that serves object data, and the companion BlueFS that keeps the metadata. And they use partially the same device with cooperation, but the same device using different block device handlers for architecture simplicity reasons. That's why we have that weird open with non-exclusive mode. But
right.
Ilya, I can
so if you
retain existing locking and add new locking, and that could be selected by some flag, but I'm not really sure if that's the right way to go.
Yeah, but that's exactly what I'm saying, that we don't need, that we probably, like, I'm 99% sure that we don't need existing locking, and we could just switch to or exclusive locking and like not expose this implementation detail at all. So the BlueFS code would still invoke this set no exclusive lock method when it needs it. But there was actually another concern that I brought up in your PR is, are we sure? Because the way, like, I didn't follow all the, the entire call chain, but lock exclusive is unset. So set no exclusive lock is called in minimal open BlueFS method.
Yes, you are correct. You are correct about that. That's an
yeah. So that method is called from a bunch of places, and I just wanted to you or someone else to verify that like all those, like that there isn't a case there where that is where things could go wrong and we could still end up with the same log device opened twice in the end of the day, one of these opens needs to be exclusive and the other then can be non-exclusive. That would work for the case of opening the block device in two different ways. As long as one of them is exclusive, then we are protected. And I just wanted us to verify that that is the case in all cases, and there isn't a corner case where we are where set no exclusive lock is called on all on all the ways that the block device is opened for that particular OSD.
You are, of course, correct, and I must tell you that with your comment, you put it to light to me that our previous locking was not even used in some scenarios. So that was an error in our tooling anyways, even with the previous locking. So that didn't change.
Okay, so it sounds like the or exclusive change kind of stands on its own, but there would be an additional PR needed to fix this minimal open BlueFS stuff, right?
Yes, possibly in two PRs, because we should also maybe fix the previous versions. I don't know if we want backport the same or just fix the tooling. I would be mostly for replacing existing logs with O exclusive. I don't really want to track another customer problems related with suddenly running multiple OSDs on the same dataset.
Right, but once again, I mean, going back to my point that, and to what you seem to be confirmed that there are cases where the existing support for exclusivity, whether it works in all cases or not, like whether the container environment can fool it or not, that there were some
we were not using clocks.
Yeah.
We were not using clocks where we should have been.
Yes. So the change to O exclusive is not going to take care of that, because you would still not be using O exclusive in those places,
Correct.
right? Because, yeah, so that's what I'm saying. It's either two different PRs or at least two different commits, because these are clearly different changes, right? One is a change of the underlying locking mechanism, and the other is using the locking mechanism in more places.
Yes.
Okay, sounds good.
All right, we're already out of time. Any last thoughts on this topic? And I don't think we have time to take any more. So thank you everybody for joining. I think it was a good meeting. See you next month.
Thank you very much. Bye.
Thank you, guys.
Thanks, everybody.
Thank you. Bye.